So section 9.3 is on page 640 and it's about the quadratic formula. So this is going to be one more method for us to be able to solve quadratic equations. On that page, on page 641, we have the quadratic formula. So we have a quadratic equation ax squared plus bx plus c equal to 0, and the solutions for this quadratic equation are going to be two solutions. So the formula is minus b plus minus square root of b squared minus 4ac and everything over 2a. So usually I like to break this fraction into parts, and in that way the students may less number of mistakes. So for example, instead of having this, I used to have x equals minus b over 2a plus minus square root of b squared minus 4ac also over 2a. So in that way, sometimes it's easier to understand how those two solutions are going to be worked out. So the radical here is known as the discriminant of the equation. So usually the discriminant of the equation, usually called d, is going to be just b squared minus 4ac. So usually if you compute this first for any quadratic equation and you find that the radical is a perfect square, if the radical is a perfect square, that's an indication that the quadratic equation can be factored over the integers. So if the radical is a perfect square, the quadratic equation can be factored over the integers. So this is something that usually we cover in Math 13, but it's good for you to know that now. So I'm going to start with example 1. Example 1 is on page 641 and is about solving the following equation. In this case, we're going to use the quadratic equation. Later, you're going to use any method from the ones that we learn in this class. So you can use the quadratic formula, you can use do factoring, you can use the completing the square method. So in this case, we're going to solve using the quadratic formula. And the equation that we're going to solve is 2x squared plus 9x minus 5 equal to 0. So the formula is x equals minus b plus minus the square root of b squared minus 4 times a times c over 2a. So we need to identify the coefficients a, b, and c. So from this equation, you can see that a is going to be equal to 2, b is going to be equal to 9, and c equals to negative 5. It is important that you have the equation, the algebraic expression on the left-hand side should be equal to 0. If there is a different number here than 0, then you need to do the math to have everything on the left-hand side. Also, you need to have your quadratic equation written in descending orders or power of x. So you have to start always with the quadratic term. This is the quadratic term. This is the linear term. And this is the constant term. So those are the names. So once you have identified a, b, and c, you just need to replace, you need to do the substitution. So you need to replace b, a, and c by their corresponding values. So in this case, minus b is minus 9 plus minus square root of b squared, so it's going to be 9 squared minus 4 times a is going to be 2 and c is going to be negative 5, and this is over 2 times a, which is 2. So let's do the computations that are indicated here. So we're going to have x equals negative e. So you're going to work first with the radical. Try to simplify the radical. Now you know how to work with radicals. So that's the first step. Simplify the radical. So don't forget the radical sign and just do the operations that are indicated inside. So it's going to be 81. Then negative times negative is going to be positive. And then you have 4 times 2 is 8 times 5 is going to be 40. So this is going to be 81 plus 40 over 2 times 2 is going to be 4. So now we need to continue with the radical. We need to simplify this radical. So we have negative 9 plus minus, and 81 plus 40 is going to be 121. Then if you remember, this is a perfect square. Otherwise, you need to simplify the radical by factoring the radical in two numbers. Remember, one is going to be a perfect square, the other one is going to be a non-perfect square, if that is possible. Sometimes you cannot factor the radical and you leave it as that. So in this case, 121 is a perfect square. So we can write that as negative 9 plus minus, and 121 is 11 square, then over 4. So 11 square and so the exponent and the radical can be cancelled. So we remove this exponent, we remove this radical sign. So we're gonna end up with negative 9 plus minus 11 over 4. So now we have two solutions because we have a plus minus here. So the first one, I'm going to use the subscript 1 for the first one, and I'm going to use one of these signs only. So it's going to be negative 9, negative 11 over 4. The other one is going to be negative 9 plus 11 over 4, and then you just finish this computation. So negative 9 and negative 11 is going to be negative 20 over 4, so this is going to be negative 5. On the other hand, negative 9 plus 11 is going to be 2 over 4, and then you just simplify this fraction, dividing by 2 both the numerator and the denominator, so you're going to get 1/2. So these two solutions can be written by using the set notation. So we use a curly brace, then we write first the most negative one, so it's going to be negative 5 comma 1/2. So that's the solution for this first problem by using the quadratic formula. So I'm going to solve one more problem, and then you're going to have the time to practice and use the quadratic formula. So we have example 2 on page 642. So we're going to solve using the quadratic formula. Okay, the problem is 2x squared equals 6x minus 1. So the first thing here is that you see that on the left hand side is just you only have the quadratic term. On the right hand side you have the linear term and the constant term. So quadratic term, linear term, constant term, and we need all of them on the same side. So we're gonna move everything to the left hand side. So first we're gonna subtract 6x from both sides of the equation. So you get 2x squared minus 6x equals -1, and then you're gonna move -1 to the other side by adding 1 on both sides of the equation. So you're gonna get 2x squared minus 6x plus 1 equal to 0. So in this case, we have A equals 2, B equals -6, and C equals 1. So let's use the formula. I like writing the formula all the time to memorize it. You're gonna have the opportunity to use your formula sheet for your final exam, but it is good to memorize this formula. It's a very useful formula. So let's see. I'm going to start with negative b. Negative b is just the opposite of -6, so it's going to be positive 6. Then plus minus, then -6 squared. So don't forget using a parenthesis when you have a negative number that you're going to square to prevent mistakes. Then you have minus 4 times a times c, and everything over 2 times a. So now we're going to proceed to simplify the radical first. So we're going to have 6 plus minus a -6 squared is going to be 36. And then you have -4 times 2 is going to be negative a over 4. Then we continue with the radical, and then you have 36 minus 8 is going to be 28. So that's the radical, 28 over 4. Then you have here, you need to simplify now this radical. We need to break this in two parts. So first a perfect square 4, then the non-perfect square 7, because 4 times 7 is going to be 28. 4 is a perfect square, 7 is not, over 4. So now you can rewrite 4 as 2 squared, remember, times the square root of 7 over 4. Okay, let's continue on another page. So we have now that x equals 6 plus minus, you cancel the radical and the exponent and you get only the number 2 times the square root of 7 over 4. So to simplify this, we're going to break now this into fractions. So one is 6 over 4 plus minus 2 over 4 times the square root of 7. So sometimes it is good to break the fraction into fractions. In that way, our math is going to be easier. So I have to simplify now these fractions that are here. So 6 over 4, you divide by 2, the numerator, you divide by 2, the denominator, you're going to get 3 over 2, plus minus, and you divide by 2, the numerator, and by 2, the denominator, so you're going to get 1 over 2, and this is times the square root of 7. So now you have your two solutions here. So one solution is going to be just 3 over 2 minus 1 over 2 the square root of 7, and the other one is going to be 3 over 2 plus 1 over 2 the square root of 7. So you can write this as 3 over 2 minus, you can just multiply 1 and the radical, you're going to get the square root of 7 over 2, and also here 3 over 2 plus the square root of 7 over 2. So you can present the solutions in this way, or you can use have also a common denominator. So the other way to present this is 3 minus square root of 7 over 2, comma 3 plus square root of 7 over 2. So you might ask, why did I break the fraction here in two parts? I did it because sometimes the students, when they try to simplify this fraction, they only divide this number and this number by 2, for example, in this case, so they get 3 and 2, but they don't do anything with this number. So that means that they're going to get the wrong answer. So when you have fractions, and especially when you cannot combine the numerator, so you have a radical and a non-radical, it is good to break the fraction to see whether you can simplify the resulting fractions. And once you finish simplifying, you can go back and get a common denominator. So, but if you can do the math, the simplification without breaking the fraction, do it. But if not, you better break first the fraction, do all your math with the fractions, simplify, and then you combine the final result into a single fraction. So this is the problems that, these are the problems that we want to solve for this class. Now you're going to start solving from 9.3 exercise set on page 647. So you're going to solve a lot of problems, so we have plenty of time for that, and with that you're now practicing for the final exam. So you're going to start with problem 2. So x squared plus 7x plus 10 equal to 0. So in these first exercises, use the quadratic formula. There is a second section that we're going to cover a little bit later, where you're going to use any method to solve the quadratic equation. But for these ones, try to use the quadratic formula. And the other important thing is that when you use the quadratic formula, you're practicing your math on radicals. So it's good. It's a good practice for radical expression math. So number 4 is x squared plus 5x plus 2 equal to 0. Then we have problem 6 is x squared plus 2x minus 4 equal to 0. Problem 8, x squared plus 4x plus 1 equal to 0. And let's start with only 5 problems. So problem 10 is x squared minus 3x minus 10 equal to 0. So solve these problems, and you either send me your answers by using the chat box, or if you are watching the video, the recorded video, then you need to submit your work by using the corresponding classwork section on Canvas. So let's solve problem 8 from this set. So we have x squared plus 4x plus 1 equal to 0. The first thing, we need to identify the coefficients. So what is the coefficient of x squared? Is just 1. What is the coefficient of the second term? Is just 4. What is the coefficient of the third term? Is going to be 1 again. So we have the three coefficients, a, b, and c. Now we are going to be able to apply the quadratic formula, which is minus b plus minus the square root of b squared minus 4 times ac, and everything over 2a. So we have here minus b is minus 4 plus minus. Now b squared is going to be 4 squared minus 4 times a, which is 1, and c, which is 1, 2. over 2 times a, which is 2 times 1. So now let's work on the radical first. So we have 4 squared is going to be 16 minus 4 times 1 is going to be 4 and over 2. So we continue simplifying the radical. So here you're going to have negative 4 plus minus the square root of 12 over 2. So now I'm going to break, first I'm going to continue working in the radical. I need to simplify this radical. So I'm going to break 12 in a perfect square part and then a non-perfect square part. So what are those factors? So I have minus 4 plus minus, then 12 is going to be 4 times 3. So it's going to be 4 times 3. And remember, I need to write first the perfect square and then the non-perfect square over 2. So you get negative 4 plus minus. Now the perfect square, we're going to write it in an exponential way. And then the square root of 3 remains as that. And finally, we have negative 4 plus minus. Then we can cancel the exponent and the radical. We get only 2 times square root of 3 over 2. Now this is the important part because some of you are making some mistakes when you are in this part. So you need to be very careful with your math involving fraction. So here I'm going to break first the whole fraction into parts. So I'm going to divide the first part by the numerator, and the second part is going to be divided also by the numerator. So I'm going to get negative 4 over the numerator plus minus, then I have 2 times square root of 3 also over the numerator. You need to do this to prevent mistakes. Then you can simplify this fraction. So in the first case, you can just check negative 4 over 2 is going to be just negative 2. Then that's the first result, so there is no longer a fraction. With respect to the second one, you have also the same thing. 2 divided by 2 is going to be 1, so you're going to get 1 times the square root of 3. So finally, you can just write the answer in this way, or you can enumerate the solutions. So we have the first one is negative 2 minus 1 times the square root of 3. You can write just in this way. You don't need to write the 1. And the other one is going to be negative 2 plus the square root of 3. So this is the solution for problem 8. So now I'm going to work one more problem, and I'm going to assign up more problems because I think you need a lot of practice with quadratic equations. So I'm going to solve problem 12 from the same exercise set. So we have now 9x squared minus 12x minus 5 equal to 0. So that's problem 12. So again, we need to identify first our coefficients. So A is going to be 9, B is going to be negative 12, C equals negative 5. So don't write x squared here or x here. So we only write the coefficient. So there is no variable involved here. So please, because sometimes you write x squared here or x here. No, we only need the coefficients. Then we're going to use the quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a. So we're going to need to replace every piece of the formula with the corresponding value. So the first one, negative b. So negative times negative 12. So negative is going to be positive 12 plus minus b squared. B is negative, so I'm going to use a parenthesis to prevent mistakes, because any negative quantity that is squared is going to become positive. So now minus 4 times A is 9 and C is negative 5 over 2 times A. So now we need to do our math. So we need to simplify this. So you're gonna get 12 plus minus the square root of 12 squared is gonna be 144. Then you have negative times negative is gonna be positive. And then we have 4 times 9 times 5. So that is gonna be, you can use your calculator. So you're gonna get 180 over 2 times 9 is 18. So we continue simplifying the radical. So you get 12 plus minus, and now you have 144 plus 180 is gonna be 324. So we're gonna get 324 over 18. So now we need to check whether 324 is a perfect square or not. So let's check that. So yeah, it turns out that this is a perfect square. So we're gonna get 12 plus minus, and 324 is 18 square over 18. So we continue our simplification. So you can remove the radical sign and the exponent. So you get 12 plus minus 18 over 18. So now work on each solution. So the first one is gonna be 12 minus 18 over 18, and the second one is gonna be 12 plus 18 over 18. So we only need now to complete this fraction math. So 12 minus 18 is gonna be negative 6 over 18. We're gonna divide by 3, both the numerator and the denominator. We're gonna divide by 6 actually. If you divide by 6, you just get okay, let's do, I did negative, I divided by 3, so you're gonna get negative 2 over negative, sorry, positive 6. So, and then we divide by 2 now, so you're gonna get negative 1 over 3. So that is gonna be our first solution. The second one is we need to add now 12 and 18. That is gonna be 30 over 18. So the same thing, we're gonna divide by 6, both the numerator and the denominator. So you're gonna get 5 over 3. So that is gonna be the other solution. So the final answer then is gonna be negative 1/3, comma 5 over 3. So that's problem 12. So now I'm going to assign you 5 more problems, and then I'm going to give you problems where you're gonna apply any method to solve the quadratic equation. So now you're gonna solve problem 14. 14 is x squared plus 6x minus 10 equal to 0. So 16 is gonna be x squared minus 5x equals 10. Problem 18 is 3x squared minus 5x plus 1 equal to 0. Problem 20 is 4x squared plus 12x plus 9 equal to 0. And finally 22 is 3x squared equals 6x minus 1. So solve these 5 problems, and again you can show me your answers through the chat box, or if you are watching the recorded video, then you just need to submit your classwork through the corresponding assignment on Canvas. So I'm going to solve problem 16. Problem 16, you have x squared minus 5x equals 10. So the first thing that you need to do is you need all the quadratic equation on one side of the equation, or the quadratic expression, the algebraic expression. So I'm going to move this 10 to the left hand side, so I'm going to write minus 10 and minus 10 here, and by doing that I'm going to get x squared minus 5x minus 10 equals to 0. So now we can identify our coefficients. So the first coefficient is just the coefficient of the quadratic term, is just 1. The second coefficient is the coefficient for the linear term, is just -5. And finally, the last coefficient is just the constant term, which is -10. So now we have the coefficient. Now we can apply the quadratic formula. So I'm going to write here the quadratic formula, and then I'm going to do the substitution. So I'm going to replace b by -5. So negative b is negative here is going to be positive 5 plus minus. Now b squared is a negative number. I'm going to use a parenthesis to prevent mistakes. So I'm squaring -5 minus 4 times a, which is 1, and c, which is -10, then over 2 times a, which is 2 times 1. Then we're going to work on the radical. So we have 5 plus minus -5 squared is going to be 25. So anytime that you square a quantity, regardless whether it's negative or positive, the answer, the result is always positive. So the square of any number, negative or not, is going to be positive. Then -4 times -10 is going to be positive 40. Then over 2. Then we need to simplify the radical. So it's going to be 5 plus minus the square root of 65 over 2. So you're going to see that the 65 cannot be broken into parts, one of those being a perfect square. So we're going to leave that radical in that way. So we finish because we cannot simplify anything. So the final answer is just 5 minus the square root of 65 over 2, and the other one is 5 plus the square root of 65 over 2. So that's this problem. Now I'm going to solve another problem. This problem is problem 33 on page 648. So problem 33 is 3x minus 4. This binomial is square, and this is equal to 16. So here you can see that your variable is on the left hand side. There is no variables on the right hand side. So, and also you just need to see that this is a perfect square too, because this is an expression that is squared. So this is a perfect square. A perfect square. So when you have a perfect square equals to a number, then you just apply the square root property. That was the first method that we learned to solve quadratic equations. So we're gonna take the square root on both sides of the equation. So I'm going to take the square root here, and then I'm going to take the square root of here. But remember, the square root on the right hand side is going to be preceded by a plus and a minus. So now we can cancel. So the exponent and the radical. So we have 3x minus 4 equals plus minus. And now here you have 16, which is a perfect square. So you can write 4 squared. And the same thing, you can cancel the radical sign and the exponent. So we have 3x minus 4 equals plus minus 4. So now we need to find two solutions. So we're going to write the first one is 3x minus 4 equals, and we're going to use one of the signs, negative 4. The other one is 3x minus 4 equals. Now we're going to use the plus sign. And we have two linear equations. We're going to solve this linear equation. So we're going to add 4 to both sides of this equation. So we get 3x equals 0. Then you divide by 3 both sides. So you're going to get x equals 0. So 0 divided by any number is 0. With the exception if you have 0 over 0, this is undefined. Or if you have any number over 0 is also undefined. But when you have 0 over a non-zero number, then this is going to be 0. So on the other hand, we have here that we're going to add 4 to both sides of the equation. So we're going to get 3x equals 8. We divide by 3. So we're going to get x equals 8 over 3. So we have these two solutions. So we're going to write that x equals 0, a over 3. So that's problem 33. So now I'm going to give you the last 5 problems for you to solve. And this is a good practice because you're practicing radicals, you're practicing fractions, and you're also doing operations okay, with radicals and non-radicals. So let's see, you're gonna work now problem 24. Problem 24 is and you can use any method. So for these ones is solve the quadratic equation by the method of your preference. And that's what you're going to do in the exam, in the final exam. So you can use any method. So 24 is 3x squared minus 4x equals 4. Then we have 28 is 2x squared equals 250. Then we have problem 32 is 2x minus 5 times x plus 1 equals 2. Then we have problem 34, and this is going to be 2x plus 7 squared equals 25. And finally, problem 40 is just x squared minus 6x equals to 0. So we have here 5 problems to solve, and that is going to be all for today's lecture.